All right. So as Steve said, my name is Brendan Leach. I am a Microsoft MVP in the data platform category and have been so since 2016. I currently work for a financial company whose name I am not allowed to disclose, and I function as a SQL Server infrastructure architect. So what does that mean? That means I spend a lot of my time designing the system infrastructure itself and the and building automation around it to enable our environment to be managed as easily as possible. That means a lot of automated issue resolution, etc. So give me 1 second and I will share. So my screen. So now that I've got that up. So if you want to reach me, you can do so either through Twitter or directly through my email address. It may take me a little bit of time to respond. I tend to keep rather busy, but I will get back eventually. It just may take a day or two. Now, we're here to talk about partitioning. So this session is designed for the conference format, and we're going to talk about what partitioning is. We're first going to discuss what horizontal versus vertical partitioning means. That tends to confuse people quite a bit, but I've got a handy graphic that will help you understand that. I think that person is trying to get back in, by the way. Then we're going to talk about partition views, which is an older way to partition your tables, but is still very much valid to use. And actually will allow us to look at what's called partition elimination very easily. We can see it there right in the query plans, front and center. Once we've done that, we'll discuss the actual table partitioning feature and how it works and how it's different from partition views. We'll discuss when and why to partition, and we'll talk about the real benefits of partitioning in terms of maintenance of our databases. Now, we'll also briefly touch on column store and partitioning as we go throughout the presentation. And just to do a quick check, everyone is seeing my slides okay?
Yep.
Perfect. All right. So what is partitioning? Partitioning is the act of taking a table and breaking it up into smaller chunks. Now, we have two different types of partitioning. We have horizontal and vertical partitioning. So we can think of horizontal partitioning as breaking things up into buckets of rows, right? We're putting our rows into different buckets. That way we can manage those buckets easier. We don't have to read from certain buckets if unnecessarily. Vertical partitioning is when we split out columns into subtables. For example, we often do this with normalization just naturally, but sometimes we may want to do this because there are certain columns that are less frequently accessed, and we can get a better page density if we vertically partition. A quick example of vertical partitioning was I once got a 400 column table. And this was probably the worst table I'd ever seen. It had 400 columns. All the columns were varchar 8000, and the data was padded. So you couldn't even fit a single row on the page. It was that bad. Biggest benefit was obviously using the right data type, but an absolutely huge benefit, second to the data type change, was to simply remove all the not frequently accessed columns from the main table and put them in a separate table. This gave us a much greater page density, meaning more rows per page, and thus we had to read less off disk to get at the data that we actually wanted. Most of what we're going to focus on, however, is horizontal partitioning. This is what we traditionally think of when we think of table partitioning or partition views. So let's talk about partition views for a second here. So the idea behind partition views is we have separate base tables, and those base tables have constraints on. As you can see here, we've got a constraint for each of these three tables defining data for a specific month. For example, table 1 can handle January data, table 2 February, and table 3 will handle March. On top of this, we layer a view using a union all. And SQL Server is smart enough when you query that view to look at what's in your where clause and compare it against the constraints. And it'll say, oh, you're querying for February 4th. Well, I know that data can only exist in table 2. So that's the only table I'm going to query. And we can see this if you give me 1 second to pull up my RDP window. So if I go over to my partition demo, this is how we've defined the view. In this case, we've got 2 tables. We have an orders archive, and we have a current month orders. Now, this data is from 2013, so keep that in mind. Additionally, on the table, we've got these 2 constraints. Now, if we go and we check sys.check constraints, this is important. There is a field in here, is not trusted. Now, if you have, for example, disabled the constraint, if you disable the constraint, you insert into it and then you re-enable it, and you do not check that constraint or do not tell it to check itself, it will be not trusted. And what that means is the optimizer will not use it when generating query plans. So you can query sys.check constraints to see if your constraints are trusted. And a value of 0 indicates that these 2 constraints are in fact trusted. So we know that the optimizer will take advantage of them. So let's go down and let's actually query just the view with no where clause. And I am going to simply display the estimated execution plan. Now you can see that it does a table scan against both current month orders and against orders archive. So this is as we expect. Now, if I query it with the date of 10/30/2013, we will see the impact of partition elimination. So if I display the estimated execution plan again, we can see that it looked at the constraints and realized it only needed to scan the orders archive table. So that's exactly what it did. Now, by the same token, if I go and query for November 2nd, 2013, we'll see that that table scan is now against current month orders and not orders archive. Now, I'm going to ask quickly if any of you notice anything about these two constraints. Feel free to just unmute yourself and speak, or to type it in the chat. You see anything in the chat, Ross?
No, I don't.
All right. So if nobody has picked up on it, there's a missing day. Current month orders doesn't allow for November 1st, 2013. And orders archive only goes up to the 31st of October. In other words, we can't insert data for November 1st into either of these two tables. So my question is, my follow-up question is, does anyone want to hazard a guess as to what happens if we query for November 1st? What our execution plan is going to look like? Again, just unmute yourself and speak up, or post in the chat.
I don't know what the execution plan is, but I'm just assuming nothing's going to come out of it.
Nothing will come out of it because there's no data for that date. But let's let me show you. We get the easiest execution plan SQL Server will ever deal with. It literally just returns nothing. And the reason is because it looked at the constraints, realized it had there was no possibility for that date to return anything, so it didn't touch either table. It simply looked at the metadata and gave up. So this is partition elimination. On larger tables, this will significantly reduce query time, because SQL Server is able to say, hey, there's chunks of this I don't need to even look at. And so the optimizer takes advantage of that, eliminates the partitions, and we end up with better plans. Now, what do I mean by larger tables? Because that's relative. What I would consider a larger table is probably not what you all would consider a larger table. For some of you, it'll be similar, but not for all. For me, a large table is anything over a terabyte, right? I work in an environment where we have tables measured in tens of terabytes. They are very large tables. They require, you have to work with them differently. And without something like partitioning, it would be a nightmare. Now, the great thing about partition views in this scenario is we can make as many base tables as we want, right? We can have we can do index maintenance on just those base tables, or one or two of them, right? So that makes maintenance a little easier. We don't get we still get some stats benefits, but the problem with partition views is they're complex structure that our developers have to be aware of when designing applications that work against us. For example, you can't easily insert directly into the view. There are some cases where you will be able to, but for the most part, they need to be aware of the base tables so that they can insert and update the data appropriately. And if you're changing a date upon which you're partitioning, well, then you're going to have to remove from original base table and insert into the correct base table, right? So it's a lot of additional work at the application layer. So let me go back to, or let me just minimize this, sorry. And let's start talking about table partitioning. Now, this is a really great feature. It is mostly invisible to your developers and to your queries. As such, it's more flexible, right? If you're using column store at any level, partitioning is an absolute must, right? It's one of the key things that you want to do, in addition to inserting exactly n number of rows at a time, because of how column store, handles inserts, updates, and deletes. Also, a lot of the index and stats management becomes a lot easier. If you're using Ola Hallengren's maintenance scripts, for example, which I do highly recommend, you will find that his scripts take partitioning into account. When we get to maintenance, I'll show you how to look at the fragmentation of individual partitions. And I'll also explain the benefits that Microsoft has and changes Microsoft has made to auto updates of stats. There's now this thing called incremental stats, and we'll discuss what that is later. Additionally, table partitioning can help you improve the efficiency of data loads through what's called the sliding window technique. Now, on the downside, behind the scenes, things get a lot more complex, right? Partitions require maintenance. There is actually a limit to the number of partitions you can have, and I hope you never hit that. But we do want to get rid of or merge older partitions as time goes on. Maybe we've got a monthly cadence, and we want 4 partitions total. The current month and the previous 2 months, so the quarter, as 3 separate partitions, and then the last 9 months as a single partition. So this feature was introduced in SQL Server 2005. Originally, it came out as an enterprise-only feature. However, in 2016 Service Pack 1, they made it available to standard as well. They actually brought a whole bunch of features to standard. And as I mentioned, it's invisible to queries. 2014 introduced what are called incremental stats. That's that stats benefit where they actually introduced the feature that changes how stats updates occur, the formula behind the scenes. And in 2016, they introduced partition truncation. This made it a whole lot easier. Prior to 2016, what we would do is we'd use this command called alter table switch, and I'll show you that a little later. I'll walk you through a sliding windows demonstration that it's not fully functional yet, but should be soon. But I will walk you through it so that you see how we would use the alter table switch command, which allows you to take a partition of table A and make it a partition of table B, or even out, and thus even out to a whole new table. So what we would do is we would slide, or we would switch the partition out to another table that we would then drop, and that's how we would truncate partitions in the past. Now we can just write a truncate statement. So in order to understand table partitioning, we have to understand a little bit about how things work inside the database itself. So on a typical database, you will have at minimum the primary file group, right? And you may or may not have other additional file groups, and then you will have your log file. Each of those file groups will have at least one file. Most will have more. When we create a table, normally what's happening is the table gets built on one of those file groups, default is primary, and the data gets spread across both files, or as all the files, I should say. In this case, we're showing just 2 files. However, when we partition, what happens is we build our table on top of a partition scheme, which will split the data across one or more file groups, right? So we get our partitions from the scheme. Those partitions are assigned to file groups. They can either be assigned all to the same file group or to different file groups. And each of those file groups, as we stated, has their own set of data files. So you can see much simpler without partitioning, more complicated with partitioning. Now, here's a secret. You're using partitioning today, even if you're not using partitioning today. The reason for that is every table by default has a minimum of one partition. You can create and partition a table across 20 or 100 partitions if you want. But even a table you haven't partitioned has a single partition. Now, why might you want to send data to different file groups? Well, you may have parts of your table that are, less frequently accessed. You might want to put, for example, more frequently accessed data on all flash storage. And then you might want to put older data on spinning rust. You can do that with partitioning. That was a common use case back in the day. What's more common, however, is that you will send all of your partitions to a single file group. Because in most cases, you're partitioning to make maintenance easier and to get partition elimination. So how do we actually partition a table? Well, the first thing that we need to do is to define our partition boundaries. And to do that, we create what's called a partition function. Now, for a partition function, we define a list of boundaries, and then we specify, what side of the line those boundary values fall into. So in this case, we're specifying range rights. And that's typically what we're going to work with when we're doing date-based partitioning. So in this case, it's going to create a boundary point for January 1st, 2023, right? Then it's going to create a boundary point for February and the same for March. And January 1st is going to fall into the bucket on the right. So in this case, it's going to give us a bucket for data prior to January 1st as well, right? That way there's some place for that data to fall into. If we had specified range left, well, then February 1st would fall into the same bucket as, say, January 25th, and we don't want that. So once we've defined our boundaries, essentially our buckets, we have to define our partition schemes. So partition schemes are used to define where our buckets go. So a scheme references the partition function. You can see that here on the second line at the bottom, and contains a list of file groups. In this case, everything's going to the primary file group. So you'll see that we defined 5 here, whereas if we go back here, we see we've got 4 buckets. Well, it's using that last one to say the next file group the next time we split this scheme, meaning we make a new bucket, it's going to go to primary as well. We also have a shortcut here we can use. We could simply say all to primary, and everything would be sent to the primary file group.
Hey, Brandon.
Yes.
Excuse me, Brandon. We have a question.
Perfect.
And it says, can you back up or restore individual partitions?
You can back up or restore individual file groups. So if your partitions are on separate file groups, you might be able to do it. I've never actually run into a use case for that though. So I won't 100% guarantee, but I would think you could do it that way.
I've never
Okay, thank you.
I've never worked on big tables, terabytes level on partitioned in SQL Server, but ages ago in DB2, we had a couple partitions go bad that were on their own file group, and we were able to restore them. So I was curious if you could do the same thing with SQL Server.
I would think you could, but it's something I would have to test. Right. It's not something I've ever had a need to do. I generally haven't worked with file group backups, or partial backups as they're called. Any other questions? All right. Feel free to just interrupt and ask questions as I go. That's totally okay. And in fact, I've allotted time for that. So if you don't ask questions, we're going to end this presentation earlier than expected. So before I go into the demo, I want to talk a little bit about the internal structure of a table. So as I've mentioned, a table at a minimum has a single partition. However, that has an impact because our data for that partition is stored in one of 3 what are called allocation units. These are storage mechanisms. So we have in-row data, which is what we think of when we use, say, DVCC page to view data. We're typically looking at an in-row data page. But then we have lob data and row overflow data as well. Lob being large object storage. It's the least efficient storage that SQL Server has. So you'll have an ancillary set of pages linked to that specific column. There'll be a forwarder in the row pointing to that chain. Really inefficient. And row overflow data, which is kind of halfway between. Multiple rows can use the same row overflow page. But the 3 of these together are going to have, so for every partition, sorry to step back, every partition you're going to have 3 allocation units. 1 for each of these that you see here at the bottom. You're also going to have IAM chains for each of those allocation units. So the more partitions you have, the more overhead there is for tracking the data that belongs to that table. So 99% of the time, it's not going to be an issue for you unless you start to go crazy with creating partitions. I think the limit was 15,000 partitions last I checked. And if you've got like 100 partitions for your table, you're doing something wrong. So we can kind of see that here, right? If we've got 3 partitions, we've got 9 allocation units total. And that means 9 IAM chains that have to be kept track of. So let's go and look at creating a sample partition table. So in this case, I've already run these commands. Oh, that's hang on, I gotta find the. We'll go here. So the first thing we have to do when we partition the table is we have to define our partition function. Again, we're using range right, and we are creating a partition function for the first 9 months of the year 2021. Obviously, we're using range right because we want the boundary point to fall in the correct bucket. So we create that. Then, in this case, we're not using the shortcut. We are creating our partition scheme, passing in the partition function, and sending everything to primary. Once we're done with that, we can use this if we want to manually assign primary to be used whenever we create a new boundary point. So this is just alter partition scheme, the name of the partition scheme, next used, primary. So that's great for orders archive. Now, I'm going to create a partition function for 3 months, specifically October, November, and December, finishing out the year, the last quarter. And this is we're going to call this orders current. The problem when you write a demo for something where you're partitioning by date is it's a pain to go back and change that year. So again, we create our partition scheme. Again, we alter it. Now, what happens when we want to go and add a new month, right? Well, we got to do some work. We can use the alter partition function merge command, and we can give it a value, and everything prior to that value, it will merge into one single partition. And that's mainly a metadata operation. Essentially, what it's doing is it's combining those IAM chains associated with our partitions to make it all one partition. Then, once we do that, everything prior to that date that you define in there will be merged into one partition. So that could take down, if we were dealing with 2013 dates here, it would have basically merged an entire year into, or everything before December into one bucket. Because we're defining the boundary point here. So, sorry, I wasn't actually expecting to show you all of this. It's not fully ready. All right. Now, one point that needs to be mentioned is we have to have clustered indexes on tables that we're going to partition. You can't partition a heap. It doesn't work. There needs to be some logical order to the data. And so when we go to actually partition a table, oftentimes we're going to recreate that clustered index. And you can see that instead of saying on primary, we're saying on partition scheme, and we're passing in the column that we want to use as the partitioning key. So let's talk for a moment about the partition key and what makes for a good key. So a good partitioning key is one that logically segregates the data, that takes it and says and splits it up nicely. So typically that's going to be a date. It could also be a customer ID in a multi-tenant database. You know, say you've got a database with different clients in it, and you might use a client ID. Because then you're probably going to pass that client ID into your queries, probably going to be in the where clause, and you're going to get partition elimination as a result. Now, so talk about this a little later. So this is great and all. Let's look at our partitions, right? Then we'll get back to kind of sliding windows overall.
Hey, Brandon,
Yes.
got another question. Can you truncate a partition?
Yes, you can as of 2016. And I'm going to show you how you do that. I just need to get there.
Excellent. Thank you.
Any other questions?
That's it for now.
So how do we see what partitions we have? Well, we have this wonderful table, sys.partitions. And if I run this query here against that with a few joins, I can see that for the orders archive table, I have 9 partitions. And we're only seeing orders archive because I've got a where clause in here, and I'm limiting it by object ID. But we have, it gives us a partition ID, the object ID, which ties to the table. It does give us a schema ID, which I've filtered out here and replaced with schema name, as well as an index ID. Since technically we partition indexes, not heaps, you know, it's important to understand that your non-clustered indexes can be partitioned too. And typically, by default, when you partition a table, if you then create an index on that table, that will, by default, be partitioned as well. And when it's partitioned on the same scheme, then it is said to be aligned. It is an aligned index. And there are benefits for that. For example, if you're looking something up in a non-clustered index, when it goes to do the key lookup, it's got less to sift through to find in certain situations. So the most interesting, however, is this column right here, rows. That is an approximate row count for your table. So anyone tried to get a row count from doing select star, and it takes forever. It maybe puts a lock on the table that you didn't expect. Well, you can just come to sys.partitions, query this, group by the object ID and index ID, and you will get a accurate row count when you sum the rows column.
Could you show the whole query there? Because I can't see it to the right of P partitions.
Oh,
the-
I'm sorry.
From sys partitions. Okay, great.
Yep. My apologies on that. Thank you for chiming in. Now, if I wanted to take this a step further, I could modify this and do group by, as I just said, object ID and index ID. And what I'm going to do is I'm going to comment out these two rows. And I am going to put a new line down here and just say T dot, what was that? That was name, comma, index, underscore ID, and then some rows as row count. Right? And, oh, sorry, what is P dot object ID? There we go. And my where clause, my group by needs to be below the where clause ID. And we'll get rid of the order by here for now. If I run this, oh, I have a syntax error. There we go. If I run this, oh, okay. Sorry, I have to put t.name in there. We will take care of that, and there we go. If I run that, it just summed up all the rows for the table. Now, as you can see, this is 10,000,001 rows, right? So this is a way you can quickly, easy get a faster count in some places. All right. So now let's talk about sliding window more in depth. So if we're going to go with what we've got previously, and we want to implement a sliding window where every month we kind of archive the 3 months back and we create a new partition for the new month. So the first thing we're going to do is we're going to create new, well, we're going to tell our partition schemes what file group to use for the new partitions. Then the next thing we do is we have to run the alter table, sorry, not alter table, alter partition function split command. And we do that and we pass it in a new boundary. Then we have to use this weird $sign function, which is the only one in SQL Server, I believe. And we pass it a value, and it tells us what bucket that would fall into. So, for example, in this case, it wants to find out September 1st, 2015. So that's going to align with if we make this 2023, right? Or 2022, sorry. That will tell us what bucket that, it will give us a partition number back. So we do that for orders current and for the archive partition ID. The reason we're going to do this is because we want to be able to switch these partitions. So when I did this in testing, I got the values 3 and 10. 3 for the current partition ID and 10 for the source partition and 10 for the destination partition. So what we would do then is we would actually run this command, alter table. We tell it our table, switch partition, and we pass in our partition IDs. So our partition numbers. So essentially what we're saying is take the third partition from orders current and send it to the 10th partition of orders archive. What happens behind the scenes is SQL Server takes those IAM chains and it changes the reference. It repoints them to the table. It's like taking a shirt out of your closet and moving it to a different closet. Or taking a book off one shelf and moving it to a different one. It doesn't matter if you have 1 row or a trillion rows in your table. As long as the source and destination table are in the same file group, it is a metadata operation. You will not incur a performance penalty. However, if you run this command and you send the data to a table in a different file group, it will have to select out all the data and insert it into the other table. It will not be a metadata operation. And so it will take time to do that. And you will probably notice that time. So this is often used in data warehousing, right? Typically what will happen is you will have a base table or you'll have a staging table that is a heap. It's got no indexes, no constraints. An ETL process will come in, it will flood that table with data. And then once the data is in there, it will apply indexes and constraints. If you've ever taken a data structures or algorithms class, you will know that this is often faster than if you already had the constraints on the table. That data can then be switched. You can use the alter table switch function and say that this table or partition 1 of this table is actually this new partition of the production table, right? Very simple, very minimal lock. The production table is still available throughout this whole thing. And there's like a 1 millisecond change where it will acquire a lock and release it if everything is in the same file group. So you can see I've been going through a lot of different stuff on here and just scratch. That's why it's not fully ready yet. Let's go back here, right? And I am going to scroll down here because we're going to start talking about maintenance. And in order to do that, I want to, oh, sorry, it's over here. So now that we've talked about how our tables are partitioned, someone asked the question, what about truncating tables? So I want to show you how you do that. So the truncate table command now has an option where we can specify either a comma separated list of partitions to truncate, or we can give it a range. So in this case, 1 to 3, and also partition 5. So if I run this and just hit execute, we're going to lose a whole bunch of data, but that's okay. Right? And now if I go back to, I think it was sliding windows over here. Let's look at our row count. You'll see that our row count dropped significantly. We're now down to 5 million rows in that table. There are
So
other things.
those deletions weren't logged. The table, it was just a meta operation. The data just
Oh,
went
it's still
bye-bye?
logged. It's still logged. There is an entry in the transaction log saying that truncate occurred. Truncate is a logged operation.
But each individual row isn't written to the database log?
No, each individual row is not. It logs that a truncate occurred on this partition. And in this way, if you initiate a rollback, it's able to reconstitute the data.
Amazing.
There is a common misconception. A lot of people think that truncate is not logged, when in fact it absolutely is logged. All right. Any other questions? All right. So let's talk about index fragmentation before we talk about stats. So I'm going to move this down for now so we can see more of this query. So what this query does is this query joins data from DMDB index physical stats with data from sysindexes and systables. And if I execute it, what we can see is that the results it gives us give us the schema name, table name, the name of the index, in this case the clustered index, its partition level, and its fragmentation %. Now, please note that when we truncated the table, we actually affected this a little bit. So I believe that so we ran it against orders archive, right? But we ran it against sliding windows.order archive. So this is a different orders archive table. It's got a fragmentation of 90% in partition 3. So let's say that I want to, defragment or I want to rebuild just partition 3. So I can come in here and I can run this operation. Right? If I do that, it's going to take a little bit of time. Oh, it took 2 seconds. So now if I go and I run this again, we're going to see that we don't have fragmentation there anymore, right? It's really low. And I'm going to let you in on a little secret. That's the only partition that has data in it right now, really. So In this way, what we would normally do is we would run a query like this. We would look at the average fragmentation percentage, and we'd make a judgment call. We'd say, a standard threshold is anything below 10%. You don't rebuild or reorg. You do neither. You just leave it. 10 to 30% fragmentation, we do a reorg, and 30% fragmentation and greater, do a rebuild. Here's the thing, though. In modern storage technology, if you are using all flash, rebuilding your indexes loses the benefit of performance improvement. The reason for that is that flash storage is 100% random access. And the point of defragmenting your indexes is to make them contiguous.
To reduce physical I/O.
Yep. The idea is you just want to be able to, on disk, you want to read contiguously. In flash, well, that's a transistor here, a transistor over there. It's all over the place. So you're not really going to see a performance hit on flash from fragmentation. It still has value if you want to, say, reclaim some space. But there is less impetus these days to actually rebuild or reorg your indexes. I'm not saying don't do it. I'm saying that there's less of a reason to. And so, as you saw, we rebuilt our index. Let's go over to incremental stats. So, when we rebuild indexes, right, oftentimes people go, well, if I didn't rebuild my indexes, I'm going to get poor performance. Well, here's the secret. Here's what's really happening. When you rebuild an index, it is rebuilding the stats. If you're on all-flash storage, the benefit you're seeing from rebuild indexes is not because of the index rebuild. It's because it rebuilds the statistics with a full scan. Now, when statistics are created on a partition table, by default, they will be incremental. And so what does that mean? Well, much as your index is partitioned, your stats essentially are partitioned. And so the formula used to be for most tables that you would get an auto update of stats after 20% of the data in the table has changed. Well, that's great for a table that's, say, 10,000 rows, because that's 2,000 rows that have to change before auto update of stats kicks off. But on a table that is, say, 1 billion rows in size, the formula kind of stinks, because it's going to take 200 million rows changing before stats get updated automatically. However, if, say, you have a partitioned table and you build stats objects on top of it, what's going to happen is it's now the new formula is 20% of a partition has to change. And then the stats for that partition get rebuilt. So if we have a 1 billion row table and it's got 10 partitions, that means we have partitions of 100 million rows apiece, right? So 20% of 100 million rows is 20 million rows. That's a lot better than having to wait for 200 million rows to change, right? So 20 million rows get updated, and now we're going to get our auto update of statistics, but just for that partition. And the other thing is, generally, I hope you are on your systems persisting your sample size, right? I know doing a full scan on a lot of tables is on all your tables can be a hard thing to do, but you always want a sample size of at least 5% of your table for performance reasons. The more you can sample without impact, the better. But if you could do a full index rebuild, you can probably do a full scan instead. So do that and make sure that your auto update of that you persist that sample size so that auto update of stats will actually use it. Now, what happens if we want to manually update stats? But just for a few partitions. Well, much like truncate and our alter index statement, we can use an option that you see here at the end. So in this case, it's just going to resample on partitions 3 to 5 as well as 7. Now, I haven't actually created this stats object. So let's do that. I have no idea how long that's great. It took a short bit of time. And now let's rebuild the stats, but just for partitions 3 to 5 and also 7. Right? So partitioning gives us a lot more flexibility as we go. Now, this is I hope you're all seeing how you can use this to better manage your table, your management, because this will help you to bring down your maintenance windows and allow you to fit more into them. And I know for every DBA in the room on here, maintenance windows, you've got them crammed full right now. And it's a struggle to get additional stuff in there. Taking charge of your maintenance around statistics and indexing through partitioning can help you with that. If you can use this, go ahead.
Does it do index maintenance on a partition table in parallel?
Index maintenance on a partition table in parallel. I mean, if it's an operation that can go parallel, yes. For example, if you are rebuilding an index, that can be parallel.
Yeah, let's say you just have one index, it's on the clustering index, it's on the partitioning index. You would think that would be a natural for parallel operation.
If you are rebuilding it or reorging it, that can go parallel. You can truncate parallel, but there's going to be no point. The SQL server is going to go, oh, this is too fast. I'm just going to run a single thread. But you can specify max stop on these operations. So yes, it can go parallel. I'm actually surprised no one has asked what size I generally look at partitioning for. So I'm just going to answer that anyways. Generally, I consider partitioning a table once it gets to 40 gigabytes of data in the table. Right? The reason for this is because maintenance operations are going to start to take longer. And having partitioning in the back pocket to make that maintenance easier is going to be a big thing. I want to partition it early enough that it's not painful because it is a rebuild of the clustered index. And if you've got an 11 terabyte table, that's going to take way too long. So you want to get it in there early if you think that that table is going to grow. Additionally, as I mentioned, through things like partition elimination, you will get some performance benefit out of this, but it is not a performance feature. It's a management feature that can sometimes give you performance, if that makes sense. So we pretty much covered everything we need to cover at this point. I will give these slides to Ross, and you can download them from wherever. But I put in this handy little thing here just to give you a general overview of how stats or the algorithm used for stats. And there's been some changes to this over the years, but this is the most common one you're going to run into. But thank you all. If there are no other questions, we can end it here.
Great. Thank you very much.
Yeah, thank you, Brandon. So next month, our next meeting will be on June 8th, and we'll be having the Couchbase folks talking about the Couchbase database. So that'll we'll be back to having a hybrid meeting then. So if you want to join us downtown, you can at Microsoft, or else join us online as well. So again, thank you, Brandon, and thank you everybody for attending. See you next month.
Thank you.
Thank you.
Thank you all for coming and having me.